In this question, he is saying that let complex numbers alpha and 1 upon alpha bar lie on the circles x minus x0 whole square plus y minus y0 whole square equal to r square and x minus x0 whole square plus y minus y0 whole square equal to 4r square respectively. If z0 equal to x0 plus iy0 satisfies the equation this, then mod of alpha is equal to. It's one of the very good question of JEE Advanced 2013. I will do this question by three alternative ways. The best way will be the first way. Note that it is given that alpha and 1 upon alpha bar lie on the circle this and this respectively. There is no any other condition which alpha and alpha bar should satisfy. The only other condition which should be satisfied is this. If I draw the picture of this given information, the picture will be something of here center is x0 y0. The first point which should be noted is the argument of alpha and 1 upon alpha bar are always equal because 1 upon alpha bar will be equal to alpha upon mod alpha square, and because obviously alpha and alpha upon mod alpha square have same argument, therefore I can say the argument of alpha and 1 upon alpha bar are same. That is, if alpha is somewhere here, the 1 upon alpha bar will be somewhere on the outer circle. But you can see very easily argument of alpha and 1 upon alpha bar are same. And now using this given information, you have to find the value of mod alpha. Note that because it is a objective question, in objective questions only correct answer is of importance. By which way we have brought the correct answer, that is absolutely not important. The way which I am going to tell you, that cannot be taken as proper mathematics, but this way is sure to be giving correct answer. Actually, for this type of ways, I have given the name magical method, and this magical method I use at many places while dealing with the objective questions. But while doing practice at home, I suggest the students to do the question by proper way also, because only proper ways develops your mathematical ability. While doing practice at home, to develop the mathematical ability is also very important. But in examination, the only requirement is to get the correct answer. Magical method never gives wrong answer, but still I always suggest the students to do the question by normal way also while doing practice at home. Now see what I am going to do for using the magical method. It is clear that the only condition given to us is alpha lies on this circle, 1 upon alpha bar lie on this circle. Looking at all the choices, you can see very easily that the value of mod alpha is a constant. Therefore, for simplicity, I take the position of alpha in such a way that my solution becomes simple. Actually, because alpha can be anywhere on this circle and 1 upon alpha bar is anywhere on this circle. Therefore, I take the position of alpha such that my solution becomes simple. I take alpha here and 1 upon alpha bar here, and z0 is somewhere here. And clearly this length is r and this whole length is 2r. That is, I can say that I am naming this point as A, B, and C. Hence, according to this diagram, I can say fx of alpha, which is a point B, divides the line joining AC into equal parts. That is, I can say B is the midpoint of AC. Therefore, alpha will be Z0 plus 1 by alpha bar by 2. Hence, I can say Z0 equal to 2 alpha minus 1 by alpha bar. And now, using this value of Z0 and the value of R, I use is mod of alpha minus 1 by alpha bar. If I use this value of Z0 and this value of R in this equation, I'll get a equation in mod alpha, and from there I can easily find the value of mod alpha. See what I'm going to do. And now, using this value of Z0 and this value of R in this equation, I'll get an equation in mod alpha, and from there I'll get the value of mod alpha very easily. See, 2 into mod of 2 alpha minus 1 by alpha bar whole square equal to alpha minus 1 by alpha bar whole square plus 2. And now, using the formula that mod of z1 minus z2 whole square is equal to mod z1 square plus mod z2 square minus 2 times real part of z1 z2 bar. And using this formula, I reach at the conclusion that 2 times mod of 2 alpha whole square plus 1 by mod of alpha bar whole square minus 2 times real part of 2 alpha into 1 by alpha. Note that real part of z1 into z2 bar is there. Z2 bar conjugate of this is 1 by alpha equal to, similarly using this formula in this portion also, I get mod of alpha square plus 1 by mod of alpha bar square minus 2 times real part of alpha into 1 by alpha. Again, Z2 bar is here and conjugate of this is 1 by alpha plus 2. And this means 8 times mod alpha square plus 2 times 1 by mod alpha square minus 4 times real part of 2, and real part of 2 means 2 equal to mod alpha square plus 1 by mod alpha square minus 2 times real part of 1 is 1 plus 2. Hence, I conclude that this is 7 times mod alpha square plus 1 upon mod alpha square minus 8 equal to 0, and this implies that 7 times mod alpha to the power 4 minus 8 times mod alpha square plus 1 equal to 0. That is, I can say mod alpha square is 1 or 1 by 7. But if I take mod alpha equal to 1, then alpha and 1 by alpha bar will become same complex number. Hence, I can surely say that mod of alpha square is 1 by 7. That is, I can say mod of alpha is 1 by root 7. And now I am going to do this question by second way. And using the diagram which I had done previously also, And now because alpha is any point on this circle, therefore say alpha is somewhere here. And because it is also clear that argument of alpha and 1 by alpha bar is same as I had proved in the first way, therefore I can say if alpha is here, then 1 by alpha bar will be somewhere here, because 1 by alpha bar lies on the bigger circle. The radius of this circle is r, radius of this circle is 2r, and 1 by alpha bar is given to you that it lies on outer circle. Hence this position has complex number 1 by alpha bar. Further, to get the relation in alpha, I will proceed in this way, that I join the points and name the points as O, A, B and C, and let us take this angle as theta. I will use cosine formula in triangle OAC and in triangle OBC, and from those two cosine formulas I will eliminate theta. Hence I will get a relation in which mod alpha, mod of 1 by alpha bar, mod z0 and r will be involved. After that, using this condition, I'll get the value of mod alpha from that equation. See what I'm going to do. According to triangle OAC, cos theta is equal to mod alpha square plus mod z0 square minus r square upon 2 into mod alpha into mod of z0. Similarly, using triangle OBC, I'll get cos theta equal to 1 by mod alpha bar square plus mod of z0 square minus 2r whole square upon 2 times 1 by this into mod of z0, and I am going to equate these two values of cos theta. I get mod alpha square plus mod z0 square minus r square equal to 1 by mod alpha square plus mod z0 square minus 4r square, and here 2 into mod alpha into mod of z0 is there, and here 2 into 1 by mod alpha into mod z0 will be here. Obviously 2 mod z0 will get cancelled, and mod alpha will go in numerator. Mod alpha from here will also come, therefore 1 by mod alpha will get cancelled. I'll get mod of alpha square plus mod of z0 square minus r square equal to 1 plus mod of z0 square into mod of alpha square minus 4r square into mod alpha square. And we have got a relation in which mod alpha is present. Obviously, by taking the value of mod z0 in terms of r, I will get the value of mod alpha. C plus r square by 2 plus 1, because mod z0 square is r square by 2 plus 1, minus r square equal to 1 plus, it is r square by 2 plus 1 into mod alpha square minus 4 r square into mod alpha square. Obviously this one will get cancelled with this one, and I am going to get mod alpha square minus r square by 2 equal to r square by 2 into mod alpha square plus mod alpha square minus 4 r square into mod alpha square. Clearly this will get cancelled, and now I have got a relation in which r square is present on both sides. Therefore I can divide by r square. I get minus 1 by 2 equal to mod alpha square by 2 minus 4 times mod alpha square. That is, I get 4 minus 1 by 2 into mod alpha square equal to 1 by 2. That is, mod alpha square equal to 1 by 7. Hence I get mod alpha equal to 1 by root 7, which I had got in previous way also. Hence C becomes the correct choice. Again, making the diagram. And as in first two ways, I told that argument of alpha and 1 upon alpha bar are same. Hence, suppose alpha is somewhere here, I can take alpha here also, no problem. And 1 upon alpha bar is somewhere here. In this way, I will find the value of r and I will find the value of 2r in terms of alpha and z0. And from those two equations, and now I am naming the points O, A, B and C. First I will find the value of length AC in terms of alpha, z0 and r. Similarly, I will find the value of BC in terms of alpha, z0 and r, and see what I am going to do. And now I am going to use the formula mod of z1 minus z2 whole square equal to mod z1 square plus mod z2 square minus 2 times real part of z1 z2 bar. Using this formula, I can say that the length AC square, that is mod of alpha minus z0 square, which is r square. Hence I get mod alpha square plus mod z0 square minus 2 times real part of alpha z0 bar, or I could also write z0 alpha bar equal to r square. And similarly for BC, BC square is equal to 2r whole square, and BC is 1 upon alpha bar minus z0 whole square equal to 4r square. That is, I get 1 by mod alpha square plus mod of z0 square minus real part of 1 by alpha bar into z0 bar equal to 4r square. And now I am going to multiply the whole equation by mod alpha square. Yes, mod alpha square or mod alpha bar square is same, and this is also equal to alpha bar. What I will get? 1 plus mod of z0 square into mod of alpha square minus, it is also clear that lambda times real part of z, where lambda is real and z is complex, is clearly equal to real part of. Hence, when alpha bar will come outside, it will go inside. I will get real part of alpha z0 bar equal to 4 r square into mod alpha square. And looking at this equation and this equation which I had derived previously, this equation I have written here also for simplicity. From these two relations I can see very easily, if I subtract the two equations, I will get 1 plus mod z0 square into mod alpha square minus mod alpha square plus mod z0 square equal to 4 r square into mod alpha square minus r square. And you can see very easily in the second way also I have got the same relation. And after reaching here, this portion I have copied as in the second way. After doing the same calculation, I'll get the value of mod alpha as 1 by root 7. You can see very easily this is same as this, only in rearranged form. Hence we have got the value of mod alpha as 1 by root 7.